Find the volume generated by rotating the region bounded by the two curves about the y-axis. Let's call the first curve alpha, the red curve, and the other curve beta. Actually, the second one is the line y plus x equal to 4. So the first parabola, it should be like this because the coefficient of x squared is negative. The second one is just a line. So y equal to 4 minus x. Let's graph that first. So for the first curve, we have y equal to that. So we know this is parabola. We want to see what is this maximum. What is the coordinates of the maximum point? So we have y equal to 4 plus 3x minus x squared. The coefficient of x squared is minus 1, so minus, and the x squared minus 3x, so we have 2 times x times 3 divided by 2. We try to get a square of something. Plus 3 divided by 2 square, so it's 9 divided by 4. Minus 9 divided by 4, we need to add that back. 9 divided by 4 and plus 4. This one gives us 16 plus 9, so 25 divided by 4. Minus something, minus x minus 3 divided by 2 square. And plus 25 divided by 4. So this one gives us that this is almost 25 divided by 4 because the first term, this is minus of something always non-negative. So we know that the maximum is when y equal to 25 divided by 4. And the equalities happen when this is 0. And this means when x equal to 3 divided by 2. So this maximum point has a coordinates 3 divided by 2 and 25 divided by 4. So here would be 1.5. So we let pick the 2 points that symmetric here, 1 point here and 1 point there. So let's pick x equal to 0. Y equal to this, and when x equal to 0, we have y equal to 0, so minus 3 divided by 2 square, so we have minus 9 divided by 4, 25 divided by 4, so 16 divided by 4, this is 4. So we know that 0, 4 belong to the curve, the red curve alpha. 0, say 0 here. This is 1.5, as we said, 3 over 2, 1.5. This point say correspond to 0. The other one would be 1.5 plus 1.5. Because this distance is 1.5. So we want symmetry. We want 3 here. This point corresponds to 3. Because the distance to this axis is 1.5. So we know for sure that when x equals to 3, y is also 4. You can double check by plugging this formula. For x equal to 3, y equal to 3 minus 3 divided by 2. So this is also 3 divided by 2 square, which is 9 minus 9 divided by 4 plus 25 divided by 4. So we also have 4. So 3, 4 also belong to alpha. So I think this is enough. to graph alpha. For beta, it's just a line, so we can pick 2 points. So 0, 4, and 4, 0. Both the 2 points belong to beta. So it's about like this: 3 maximum 1.5, 6.25, 0, 4 is here, and 3, 4 is here. The second, so this is alpha. And beta 0, 4, 0, 4, and 4, 0 belong to beta. 0, 4 is here, so we have one intersection point. 4, 0 is here. So this line is beta. So by graphing it, we also see the 2 intersection points. But we can compute that 2 intersection points. So the region we need to revolve about the y-axis is this region. How can we find the methods we use? This washer methods or shell methods? So look at this. If we revolve about the y-axis, and we should usually try with this washer methods first. And if it doesn't work, we will try with the shell methods. For this washer methods, what we will do is we slide perpendicular to the axis of revolution. So for the dish methods or washer methods, we slide perpendicular to the axis of revolution. So that's what we usually try first. If we slide perpendicular to the axis of revolution, what we obtain is this thin part, and then we revolve with about the y-axis. We get a washer. This length here gives us the outer radius, and this length from here to here gives us the inner radius. R in. So the width of this piece is delta y. When delta y tends to 0, we get dy. So we are computing the integral in terms of dy. And this is the area of the cross-section. And this means that we need to compute the outer radius and inner radius in terms of y. Compute R out and R in terms of y. So in our case, we need to compute the outer radius R outer in terms of y. But the function we are given is y equal to a function of x. Now we need to find x as a function of y. Which makes it difficult. So here we have y as a function of x. We need to compute x as a function of y. That is the first thing we need to do. So that makes it difficult. The second thing if we look at this piece over here, so the outer radius is this distance from here to here. The inner radius is from here to here, this distance. So for the same value of y, we have two corresponding points on the same curve. So we need to compute this half of the curve. We need to compute this half x as a function, say number 1 of y. And we need to compute the other half here, x as another function of y. So outer radius is this length, which is this function z2 of y. In this case, for the same curve, we need to compute two different functions, g1 and g2, in terms of y, to determine the r outer and r inner. So that makes it difficult. Both regions, we would use the shell methods in this case. For the shell methods, we will slice parallel to the axis of revolution. So what we do is slicing parallel to the axis of revolution, and by doing so, we create a partition of this segment. So this segment is on x-axis. So we have the width, here's delta x. When delta x tends to 0, we have dx. Say we have a thin strip like this. The width delta x. When we revolve this piece about y-axis, what we obtain is a shell, a cylindrical shell, which look like this. So this is a thin shell that we obtain by revolving it about y-axis. And then the volume of the whole solid is actually the sum of the volume of all these small shells. The volume of this thin shell can be computed as follows. If we cut the shell along the height, what we will get is a rectangular. And then the width of the rectangular is delta x. Delta x, when delta x tends to 0, this is dx. The height of the shell, or the height of this rectangular, can be determined from this height. So this is the y coordinate of this point minus this point. So this is this length. So for a value x, the corresponding, say, this is the blue curve beta. So this is y equal to 4 minus x. So assume in general case, this one is y equal to f of x. and the blue curve y equal to g of x, then the height is, for each value of x we have f of x here and g of x there, so this is f of x minus g of x in our case. So this is this height minus this height. The height is f of x minus g of x. In our case, f of x is this function. So the height is f of x minus g of x, and the second function y equal to 4 minus x, this is g of x, f of x minus g of x. So this is minus x squared plus 4x. This length is the circumference of this circle. So this circle has radius x. This circle has radius x. So the circumference of the circle is 2 pi radius, and in our case 2 pi x. So the volume of 18 shell is the circumference times the width is delta x times the height. Volume of 18 shell is the circumference, which is 2 pi x, times the width, which is delta x or dx in our case, and the height is this height. And the sum of all these thin shells will give us the volume of the whole solid, where x runs from this point to this point, correspond to 0 to 4. So 0, 4 we can compute it by using the intersection of the two curves. So by using the equation of the two curves, we can compute the intersection point. So the volume of the whole solid we need to compute is the sum of infinite and many thin shells, which is 2 pi x times minus x squared plus 4x, delta x into 0 with dx, from 0 to 4 in our case. So this is the formula we have: 2 pi interval 0, 4 x minus x squared plus 4x dx.